Today's lesson is based on momentum. We are going to look at lesson 102, where we talk about change in momentum. Let us start. Change in momentum is the same as other physical quantities. We know that when we say change in displacement, we actually mean the final displacement of an object minus the final displacement of the initial displacement of an object. Same as the change in velocity is final velocity minus initial velocity. So we also have change in momentum, whereby we have final momentum of an object, initial momentum of an object. So far, we know how to calculate the momentum of an object. So to actually understand how to use this equation of change in momentum will be simple. So just make sure you watch lesson video 101 of momentum. Now, expanding this equation furthermore, we know that momentum is equals to mv. So final momentum, we can put mv final velocity minus mv initial velocity. Remember, we are looking at the very same object, so it means the mass will be the same. The only thing which will change the momentum in this case will be the velocity of the object. So we can see that we have mass as our common physical quantity or variable. So we can factor out m and we are left with Vf minus Vi. So this is the expansion equation of this one. Whereby this is the mass of the object, this is the final velocity of the object, this is the initial velocity of the object. Let us look at this example. We have a ball of 0.15 kg. It's initially traveling towards the wall at 18 meters per second. It bounces on the wall and moves in an opposite direction at 12 meters per second. Calculate the change in momentum of the object. We have two ways to calculate this. We can separately calculate the momentum initially and final, or we can just use the equation and calculate. Now let us start with the first one. We need to calculate the initial momentum of the ball. Now initial, we actually mean when it moves towards. So we take right as positive, left as negative. Pi is equals to the mass is 0.15, the velocity is 18. It will be positive 18 since it's moving towards the object, the wall. We get that the momentum is 2.7 kg meters per second. And then calculating the final momentum, we are going to have the mass is 0.15, final is negative 12 since it's moving away from the wall. The answer will be negative 1.8 kg meters per second. And then from here we can use this equation. So our final momentum is negative 1.8 minus the initial is 2.7. So the change in momentum will be negative 4.5 kg meters per second. So we can see that the direction of the momentum is to the left. The change in momentum is to the left. Looking at the second way to actually solve this, which is the simplest and it's way quicker than the first way. So we can say change in momentum is equals to the mass Vf minus Vi. Change in momentum is equals to 0.15. Our final velocity is negative 12 minus initial is 18. Then the answer is negative 4.5 kg meters per second. Suppose you have this car traveling at 30 meters per second at point A. The mass of the car is 1000 kg. When it reaches point B, it accelerates to 40 meters per second. What is the change in momentum of the car? The change in momentum will be the mass, the difference of the velocity. So the mass is 1000, the velocity of the car, the final velocity is 40 minus initial is 30. The momentum, the change in momentum will be 10,000 kg meters per second. Another example, let's say we have this stationary block which was not moving, and then it was hit by this ball. This is diagram A, this is B. At diagram B, the object is no longer stationary, it's actually moving. What is the change in momentum of the object? (0.12). Final velocity is 20, initial is 0. The change in momentum is actually 2.4 kg meters per second. That's it for this lesson video. This is Wahula SJ. Thank you very much.